we've got a panel coming up all about evaluation. So I'm going to bring our host with the most onto the stage. Abby, how's it going?
Hey, what's up?
I am excited for this panel that you are going to lead right now. And before we jump on and do the full panel, I just wanted everyone to know that Abby's like one of our most frequented co-hosts on the MLOps Community Podcast. So if anyone wants to check out the podcast that we do, there is a QR code. Go ahead and take a shot of that, a snapshot, or just scan it, and you will see all the different podcast episodes that we have. Abby, if I had to put you on the spot and say your favorite podcast that we have recorded, which one would it be?
I think I'll have a hard time picking from two. One is by Alex Ratner from Snorkel, and the other is from two people I'm very good friends with now, which is Maria and Bashak.
That one just came out. So
Yeah.
If anyone wants to check out, they had this really cool MLOps framework and maturity assessment test that you can do if you are wondering where you're at with ML in your organization. They talked in depth about that in one of the most recent episodes. So I'll leave a link to that in the chat and let everyone dig in. That was a really good one, I must say. And so I just want to mention too, because there was a few technical difficulties. In case anyone cannot see or your stream got paused, like my stream did, just go ahead and refresh and it should normal, hopefully. And if it's not getting back to normal, let us know in the chat so we can troubleshoot. But you should be good. Now let's bring on the rest of the guests. First up, Josh Tobin is here with us, Mr. Full Stack and Deep Learning, and also the surprise guest of our in-person workshop that is going on in San Francisco later today. So it's good to have you here, man. I'm glad that we are getting to do this and this is happening. We've also got Sohini Roy coming up. Hello. And this is where I get to say the last person, then Abby, I'm handing it over to you to take over. All right. And where's Amrutha, you there? Yes, there it is. Okay, so now there's too many people on the stage. I will remove myself and let you all take it from here.
Okay, hi everyone. Well, so very quick intro for Josh, Amrutha, as well as Sohini. Josh is the founder and CEO of Gantry. They're working on tools to analyze, explore, and visualize. And so you can improve your models using Gantry. They have an SDK that is available. Amrutha is the CEO and co-founder of Structured.io. They're building their engineering tools for LLMs, so everything from your ingestion to your data processing pipelines. They've got you covered. Sohini is the Senior Developer Relations Manager at NVIDIA. And there's a lot to mention about her. She's been very active in the MLOps as well as LLMOps community, where one of the things we want to talk about today is the open source toolkit that they've recently released, Nemo Guardrails at NVIDIA, or any more work that they haven't released on LLM-based conversational systems. So I want to start with all of you first, because you've been in the space for quite a while, all of you, from ML to now in LLMs. How do you think, but also because now you have a company in this space, plus you're leading in for Amrutha, for Sohini specifically, you're talking to a lot of enterprise companies right now. How do you think about evaluations at your company?
Ooh, who goes first?
So Josh, Sohini, Amrutha in that series.
Beautiful. Will the expert talk first?
Yeah, I have a lot to say on this. I mean, should I just do my whole thing, or I can do the short version? Yeah, I think for those of you who have been in the ML world pre-LLMs, there's kind of a way of thinking about evaluation that we're used to, which is based on the fact that in the pre-LLM world, most of the time, the project that we're working on starts by building a data set. And most of the time, since we're training a model, we have a clear like objective function that we're trying to optimize on that data set. And so that makes a naive pass at evaluation really easy, because it's like, okay, you hold out some data from your training set, you use the same metric that you are training the model on, and that gives you an evaluation of how your model is doing. Now, that hides a lot of complexity under the rug, but I think moving to generative AI and LLMs, some of those assumptions are violated, and that's, I think, what's making this so difficult for a lot of companies to figure out. So first of all, when I start an LLM project, I usually don't start by building a data set. I usually start by thinking of what I want this thing to do, and then just coming up with a prompt to try to encourage it to have that behavior. And so that means that one of the key challenges for evaluating LLMs is like, what data do we even evaluate them on? How do we know what the right data set is to test these models on? And then the second question comes from, or the second challenge comes from violating the other assumption that we have in traditional ML, which is that, oftentimes in generative ML, we don't have a clear objective function, right? Like, let's say that you're building a summarization model. How do you measure whether two summaries of the same document, whether one is better than the other, or whether one is adequate? It's really not an obvious question. And so those two challenges, I think, are at the core of like what makes this really difficult for a lot of companies. And I'll pause there, and I think there's a framework that you can use to think through how to do this well. But I'll save that maybe for a later question.
Oh man, what a cliffhanger on that. I would say there's so many things to think about when it comes to evaluation. I agree that thinking with the end in mind first. That's definitely what we got our clients to do. Like similar to what Josh was saying. But also it's really tough when you're creating something for such a generalized environment. I think a good example of where this was interesting. Actually, you know what? We'll pause on the example because I think that'll be helpful later. But just coming back to more broadly, what do I think about evaluation? I think ultimately it comes to accuracy and speed, right? But accuracy is so dependent on what the actual goals are. Thinking about, I guess, more detailed questions. Is it helpful? Does the model actually do what you instructed it to do? And when it comes to accuracy, does the model actually answer something correctly? Is it coherent? Those are two very different ways of measuring, how accurate, how well, things are set up. I think hallucinations is another really important thing to be considering. So do the model make up any part of the response? How are you putting controls in for that? Are they deviating? Another part I think is context. So does the model actually remember what you're talking about? Are you staying on topic? And I think also for my particular realm, when we talk about the framework, NEMO guardrails, which I'm sure we can get into in a little bit for how it can actually support, but is it safe? Is it secret? Kind of like when Gandalf shakes Frodo, that's like kind of what I keep reminding my clients. Are we, is it secret? Is it and is it safe? Are we going to execute malicious code? Is it going to call an external application? Is the data set robust enough to prevent individual identifications, especially when thinking about healthcare and privacy codes, toxicity bias? I mean, there's so many different factors, but if you really had to sum it up to the top two, is it accurate and what's the speed and latency for it? But so much to talk about. This is a really great session. Amrita, what do you think?
Great answer. So one thing I always think about is when you're doing evaluation for, let's say like a classifier, there's also some notion of like what ground truth looks like, what a correct answer looks like. If you're building a classifier of like, oh, cat versus dog or red versus blue, like there's a ground truth that you can always operate from and like evaluate against. I think with LLMs, one thing that I notice is because everything is so qualitative, even from person to person, like thinking about what does a good answer look like? What does a bad answer look like? What is the expected length? How concise should it be? What kind of tone should it have? There are I think attributes of like what a good answer looks like, and that varies from like based on the expectation of the user of the model. So I feel like there's an opportunity to build an evaluation mechanism that is highly personalized, and I think the primitives of how to build that are things that are still up in the air right now, and really excited to find that.
So I think I really love the collective perspective here, but I wanna ask you more so about how do we think about that perspective for different companies? So right now there are two different kinds of interest groups when it comes to large language models. The first are the model builders, and the second are the people who are developers who are building their own application on top of these large language models. What would an ideal performance mean for both of those interest groups, and how do you decide how to think about building an evaluation framework when you're probably on each of those sides?
Yeah, I mean, I think one thing that you're pointing out is one big change that I've seen in the industry in the last 6 months or so is call it the Chat GPT effect, right? So in the old world, the olden days, back before many of you, even ML was even a twinkle in your eye. Machine learning projects were these like just really technically complex, high effort projects in most companies, right? Like I personally don't know of any examples in large companies where a deep learning project took less than, call it 6 months, and most of them took more than a year. Now, in the post-Chat GPT world, all of these companies, like you see these announcements every week or every couple of weeks from companies that are announcing their, Chat GPT powered feature. And if you talk to these folks, the amazing thing is a lot of these products were built in like weeks, like 3-4 weeks. So you ask yourself, like, how does that happen? And the answer, unfortunately, for those of us on the ML side of the house is the reason why they ship those things so quickly is because the ML people on the team didn't build them. It was the software engineers that built them. And that's not to say that ML folks don't have a role to play going forward. I think actually evaluation is one of the critical places where ML folks have a role to play. But what ChatGPT did is it really kind of lowered the barrier to entry, and also I think what's really critical is like the level of intimidation that most folks in the org have about interacting with these systems. So if you're like an exec in a company and you're sponsoring a deep learning project, you kind of like hire the nerds, the PhDs, and you let them do their thing for 6 months and you hope that something good comes out of it. But now if you're building like a ChatGPT project, you've been playing around with ChatGPT on your own. You know that it's not that difficult to get it to do what you want to do. And so what we're seeing is that a lot of folks in non-technical roles are a lot more involved in the process of building these applications than they were 6 months or a year ago. And so the implication that has for evaluation, I think, is actually really positive, which is that one of the key things for evaluating LLM-based applications is that it's I think the thing that we need to find as an industry is the right mix between automated and human-based evaluation. But the great thing about having more stakeholders involved is that you can involve those stakeholders in the process in such a way that they are helping you progressively evaluate the quality of your model as they go. And so I think, I really see like the non-technical stakeholders, sometimes are actually doing a lot of development in prompt engineering sense, but they're also like the producers of evaluations, and then the technical folks are more the consumers.
100%. I mean, like, I think that's a really great to think about it. The line is also, I think, for domain specific information, like grabbing people who have been in the industry or for that particular domain for 20, 25 years, right? And bringing that information and layering and sitting down with, software engineers, ML engineers, and actually layering that in. It's a delicate balance, I think, again, between human evaluation and automated evaluation. It's an interesting question. I have to mull a little bit on that. I don't know, Amrita, any other things to add? Josh, it's so great that you're going first. I feel like you're getting the right framework in for us.
I don't think I have too much to add on that one.
Yeah, I think that was a very, very comprehensive answer, I'll say, which is basically like, I guess it depends, which is most of this, at least my personal experience has been talking to a couple of companies, is none of the large language models, at least at big companies, have been deployed in production. We're not really talking about OpenAI. We're not talking about Google and all of those companies, but let's say about banks, which were huge when it came to financial modeling and as such, or were the adopters for machine learning models and as such. And it's great that we have reduced that time for everybody to get started and have more stakeholders, because that was one of the problems with machine learning, which is like bringing everybody together on a single table and say, let's assess what you really want out of this model. So my second question here is, we're seeing so many evaluation benchmarks right now, from Helm to to a couple of others, and there are so many leaderboards that are available. How do we create stable experimental setups to be able to evaluate and monitor the accuracy of our applications during and post deployment, LLM-based applications during and post deployment?
Maybe I can kick off on that one. So one thing I often think about is, how do you, like, anytime you have an experimental setup, you want to keep all the variables the same as much as possible. And I think, like, in this case, like having like a set of prompts that you test against and benchmark against on like a continuous basis is like super important. So one thing we've noticed, even from experimentation that we've done at our company, is you can put the same input into like GPT 3.5 Turbo, like, and it gives you a different answer like 1 hour later versus like 1 hour before. And I think that, there's like a lot of reasons for that, and it's like not like deterministic in the way that it answers. And so it's the outputs are, they're going to be different even if you have the same inputs. But I think that, like, if you do a qualitative evaluation where you keep the inputs as stable as possible, and like maybe have like some sampling and ongoing measurement of the system health, and like perhaps alerts if it like drops too low, you can turn this into like a observability problem as well in a lot of ways. And I think that building those kinds of systems will help, like help us respond when the quality of the output goes bad.
Yeah, I totally agree with that. I mean, not to do the founder thing, but that's definitely one of the things we're betting on at Gantry is observability playing a key role here. But one thing I would want to add is, I think if your role is a researcher, then or if you're in a really early stage of a project where you're kind of deciding what model to choose, then public benchmarks are helpful. I tend to prefer the sort of ELO-based benchmarks. I think they correlate a little bit better with my subjective experience of interacting with models and how they seem to perform. But if your job is not a researcher or prototyping something, but your job is building an application with language models, then you should not rely on public benchmarks. Like, they are basically almost the equivalent of useless for you in that role. And the reason for that is they are not evaluating the model on the data that your users care about, and they're not measuring the outcomes that your users care about, right? And so if you think about like measurements in machine learning in general, there's kind of like, I think of it as like a pyramid of usefulness versus ease of measurement. The most useful signal that you can always look at is outcomes, right? Like, is this machine learning, is the system that this model is part of, is that solving the problem for your end users? Difficult thing to measure, but really, really valuable to measure. And then, easier to measure, but less useful than that are things like, hey, are there proxies that we can look at, like, accuracy, or asking another language model if the output of this language model is good, that correlate with the metric that we ultimately care about. And then all the way at the bottom of this pyramid, really easy, really accessible, super low hanging fruit, but not very useful, is like looking at publicly available benchmarks. You're just not really going to learn that much about your task by doing that.
Yeah, my 2 cents, like Amrita said, standardization is king when it comes to this kind of thing. Automated testing, I think, setting up monitoring systems and those custom dashboards through that observability stack, I think is getting really exciting. I've seen a lot of really interesting tools that are doing this really well. I'm actually curious to dive a little bit more into Gantry's response to this as well. But I know Fiddler, shout out to Arise. I think their CEO or CPO is doing a presentation on this later. I think their stuff is really interesting. Hugging Face also did some custom evaluation metrics that I think make it much easier for the proper setup and making sure you're standardizing and evaluating consistently throughout. I think, Josh, you mentioned earlier doing user human feedback for iterative development ongoing, I think is going to be continuing to important for how we set up the evaluation and monitoring the accuracy long term. But you're right. I think those public standard benchmarks is probably the base, and then continuing to evaluate and use your own metrics will be super important. Yeah.
So one of the questions I wanted to ask you, because we're going into the domain of talking about, we need to have very domain-specific, company-specific benchmarks. What are the popular use cases for large language models that you've seen in production right now?
I think one example that might come to mind is I think Google's, I don't know, is it Palm, MedPalm, PALM, however they choose to say it. They released their second version, I think, back in April, and it's a really interesting case study on how to develop something that's very domain specific, because I like it because it's very much designed for purpose. I think Josh said in the beginning about how do you design the prompts and the testing data appropriately for the outcome in mind, right? How do you design for the end goal in mind? They used data sets that were in Q&A form, that were long and short answer form. The inputs were, search queries for biomedical scientific literature and robust medical knowledge. So that was actually a really, really great example of a good foundation. But I think they had metrics that also aligned, and they tested it against, I think, the US medical licensing questions as their metrics for actually determining is it successful. But in addition to that, what I liked is they reached out for human feedback, not only from clinicians to answer the accuracy of the specific responses, but also from non-clinicians from a range of backgrounds, tons of different countries and languages, to make sure the information that was coming out was accessible and something reasonable. And I think that's actually, everyone's gone on a Google spiral asking medical questions. So I think it was actually very relatable, and the results were really phenomenal in their ability and the results to answer those medical specific questions in a strong way. I hope I've kind of dug into that, but I think that's one particular example where I think that was done really well. I think another one is actually the Bloomberg GPT. I don't know if that's being done out in production, but I think as far as domain specific benchmarking and assessments for financial specific questions, that one was a really strong example.
I think the use cases that I found really compelling are in like the customer success and customer response categories. And I think like it's one of those things where being able to respond to your users quickly is like a huge win for companies, and being able to scale like customer interfacing roles is like a big challenge and can be expensive. But I think with LLMs you have like an opportunity to really like leverage like knowledge bases that you might have and expose that in a way that can like enable your customers to like interact with your product in a more meaningful way. And I think that's really powerful. There's also like a really good built-in way to evaluate the quality of responses here, because you can just ask the user like, oh, did this solve your problem for you? And you can also look at like other metrics like, oh, how often are they coming back, like how many messages did it take to resolve this issue? And there are like a lot of really great ways to kind of proxy the quality of the responses, and so I think that's a good one.
Josh, you want to add on that?
I mean, how can you, right? Sorry, he might be frozen.
I think Josh got frozen. But in the
Stunned into
meantime,
silence. I know.
Am I having a connection issue?
By the way,
no, he can move. He can move.
Okay. Yeah. my internet
Josh,
is,
we were asking if you want to add on that.
No, I mean, I think there's kind of like in terms of real use cases, there's trifecta. It's like information retrieval, search, question. One category, information retrieval. So it's things like search, document question answering, things like that. Then second category is chat. So a lot of companies are building sort of chatbots into their products. Use cases like customer support, product features. And then the third is text generation, sort of marketing, copy type use cases. Those are the three that we see the most.
Which one do you think is like most robust right now, or is doing like meeting the needs like the best right now? I'm asking because I get asked this all the time, and I never.
It depends, right? Like it's for all of these, there's such a range of complexity, right? It's like really easy to just kind of dump, Chat GPT API into your product and call it a chat app. But then how well do you actually need it to work for it to be useful? It depends a lot on the context of your product and what you're trying to get it to solve. So I would say all of them are relatively usable, depending on the broader product context. And I think this is kind of like a general point on how to think about machine learning applications in general is like, I don't think I just made the mistake that I don't encourage other people to make, which is like, I don't think makes sense to think of ML use cases grouped by like technical use cases. It's really, you should think about them in terms of product use cases, because that has a lot more of a role in determining the difficulty and challenges that you're going to face when you're building this application than what model you're using or what set of techniques you're using to glue models together. Because ultimately, at the end of the day, like things that make the thing that makes building products with ML hard is that machine learning models don't always get the answer right. That's always been true. It'll always be true. It's the nature of the technology. It's probabilistic, right? So it's not always going to be right. And so the question is like, how do you build a product in a context where one of the components of your product is going to get the answer wrong? Like that it's going to get the answer wrong. And so the broader product context of like, what does it take to actually work around that limitation is more important for the difficulty of the project than what set of algorithms you're using.
I really like the way you said that.
Yeah.
No, go ahead.
One of the things I also wanted us to touch upon, maybe probably the last question that we'll get before we open up the panel to audience Q&A, is as you're building the model, you need lots of data, and all the data may not be good. There are techniques like early stopping to be able to filter the right kind of data sets. And after that, yes, you've built your model, you're now trying to deploy it, but you're also putting some checkpoints and doing some sort of logging as well throughout the process. How do you guys think about evaluating the performance at those specific points? What tools have you seen being used, and what are the gaps that you've seen in terms of the tooling industry when it comes to Ruta, for you very specifically, when it comes to data sets, what are the gaps that you've seen? And Josh and Sohini, for both of you, I want to understand more so from like the perspective of the model checkpointing itself, as well as the prompt, as well as like the prompt drifts and stuff. So I'll let Amruta go first. Let her cover the data side of things, and then we cover the model side of things.
Yeah, absolutely. So in terms of like data set quality, it definitely makes a really big difference. I think a lot of systems are very garbage in, garbage out, and like if you start off with like a bad like baseline, you're going to be kind of disappointed with the results. And I think like oftentimes like curating the data set itself is like a really big challenge. I think like sometimes like having like rules or heuristics about like, oh, like this is like understanding your data set, like, okay, this is like the missing data, the quality of the data, like this is what's incomplete, this is what's perhaps inaccurate or not in the same form as like the rest of the data. I think like some standard data set cleaning techniques make a big difference, but then I think also curation makes a big difference. I think with a lot of these problems, like what you are looking for, you like hypothetically wouldn't really need a model as well. Like if you could define like that with words perfectly, it would be difficult to, you wouldn't really need a model to do that. It could just be like a bunch of if statements. So, you're kind of dealing with like ambiguity around what you're looking for. And so there's also ambiguity around that like curation of that data set. And so I think it's like actually an iterative process. And so like the evaluation isn't really like a one-time thing, but it's something that you have to iterate on and like try to find over time as well. Not sure if that was like fully what you're looking for, but just general thoughts in that space.
Yeah, I think that does answer. Josh, do you want to add on top of that and go into the model side of things?
Yeah, I think I'll take a slightly different position. I think I totally agree with what you're saying, Amrutha, if we're talking about machine learning, but this is the LLMs conference. And so my strong contention is if we're talking about LLMs, most of you, like most of the people in this room right now, you should not be thinking about training a model. There is very low likelihood that you're going to get better performance on an NLP task by training a model than you will by prompting GPT-4. That's just, that's unfortunately just the truth. It's a new world that we're living in. Like we've talked to like many companies at this point that had kind of ongoing NLP projects, 6-month projects, 9-month projects, year-long projects that they're able to beat their performance by switching over to large language models, calling an API, doing some prompt engineering, maybe some like few shot in context learning in a matter of weeks, right? So I think if your goal is to build products with machine learning, especially with NLP, then I think the rule of thumb is like no training models until product market fit. Like if you haven't built this thing out and demonstrated this thing can be really good using models that you can get off the shelf for NLP, then it's not going to work. Like you're not going to be able to do better by training your own model. For other domains of ML, I would have a very different answer to that question. And then on the tooling side, I think, yeah, you should just come talk to Gantry. We've got good solutions for all the problems that you just described.
Tell us about it. Give the pitch.
Yeah, I mean, the pitch is, I think the way that machine learning evolved is like, there's so much focus on training models. And our thesis kind of from the beginning, and I think this is doubly true in the LLM world, is that training models is not the hard part anymore. The hard part is you have this model, you've trained it, and you've gotten over the hump of like, the statistic that like every MLOps company used to say of like 85% of models never make it to production, which is like a BS statistic. And it's definitely not true if it ever was true, but you've gotten over that hump, you've gotten this model into production. That's when the hard part actually starts, right? Which is like, okay, how do we know if this thing's actually working? How do we know if it's solving the problem for our users? How do we maintain it, right? Like I think really common issue is, as you start to scale out the number of models per ML engineer or per data scientist on your team, the percentage of time that ML engineers spend on maintenance increases and can, quickly dwarf the amount of time that they're spending on actually building new features. And then lastly, even if you have models up and running in production and you're maintaining them, you're leaving a lot of performance on the table if that's all you're doing. Because if you think about like what distinguishes really great machine learning powered products from average ones, it's like if you look at like Chat GPT or Tesla or things like that, the thing that they all have in common is that they're maniacal about building this loop around the model building process that involves like looking at outcomes, looking at user feedback, feeding that back into the training process, right? So if you're not doing that, your machine learning powered product is just not going to be great. It could be okay, it could solve the problem, but it's not going to be great. And so what Gantry does is we basically have infrastructure, like an infrastructure layer that supports opinionated set of workflows that teams of folks working on machine learning powered products can use to collaborate on this process of taking a model that's been deployed and using production data to maintain it and to make it better over time. And so we make that a lot cheaper, easier, and more effective for machine learning teams to do together.
Sohini?
It's hard to follow that. I mean, longtime fan of Gantry, longtime fan of your blog series. So it's just
Thanks.
It's kind of nice to hear your perspective on it. I think for me, for tool sets, I know there are a couple of ones about prompt engineering that are coming out. I have to play with them a little bit more to know, which ones are the most effective. I'm getting an inkling on which one's going to be the best, but. I think from the NVIDIA standpoint, obviously we talk about guardrails a lot. It's our new open source framework that came out. We talk about, I mentioned a little bit, like, how do we make sure that even if the data in, data out problem is already, something that we're gonna, it's challenging, right? But I think if you create the right guardrails for it, so making sure that we stay on topic, making sure that, when someone asks a chatbot about your product different offerings, are you going to go and talk about competitor offerings instead of your own, right? Also making sure that you've got, I talked a little bit about like secrets and malicious code and management of external application access and interactions with, to leading to misinformation and toxic responses and inappropriate content. That's all something that we're all going to have to work through. I think guardrails will get you part of the way there. I think we're still experimenting with kind of some other tooling that can help with the rest of it, but definitely I would say check it out. It's open source. Nemo's open source. I think it might, supplement a lot of the other tools that kind of were mentioned today. I can't see any of the questions, by the way, Abby, so we're going to have to trust you to...
So I have one question. I think that's probably I don't know, Demetrius is here. Are you going to kick us off, or can we ask
I'm going to start playing the music.
Can I make a plug for this workshop I'm doing tomorrow?
Yes, do it. And then
so doing like a hands-on workshop for a full hour on this exact topic. So if folks want to learn more about it or chat more about it, I'll be there tomorrow at some time in the morning, PST. I don't remember what time, but it's on the schedule.
It's going to be really cool. Can't wait.
So, as much as I would love to continue this panel, I sadly have to cut it off because we are running short on time. And as you know, that is my one job. It's to keep us on time. And so I loved everything you all were saying, and there was a ton of questions in the chat that were coming through. So all of the panelists, it would be awesome if you jump in the chat, respond to some of these questions that came through, and I will leave it here and get you all out of here, but ask you to stick around and say a few things in the chat.